Okay, so when you hear 3D printing, what's the first thing that pops into your head? Maybe a little plastic toy or maybe a quick prototype for some gadget.
Well, you might want to rethink that because today we are doing a deep dive into 3D printing, also known as additive manufacturing. And honestly, it's way more revolutionary than you probably imagine. Our mission here is to really unpack how this technology is, well, changing everything. I mean, from the very foundations of how we build our houses to these, really ambitious ideas about colonizing other planets. We're going to explore the impact on jobs, on supply chains, even global power dynamics. It's huge.
It really is. And you're right, this isn't just about like tweaking designs anymore. What you're going to discover today are some genuinely surprising applications, connections that go way beyond just making simple prototypes. We're talking about something that fundamentally disrupts, traditional economies of scale. And it's totally revolutionizing how goods are made, how they move around the world. It's a big shift. Yeah, it's easy to get caught up on what's happening now, but I think to really get where it's going, when you take a quick look back, its journey is actually pretty remarkable. It starts way back in the 1980s. You had early pioneers like Dr. Hideo Kodama in Japan back in '81 proposing this idea for rapid prototyping. But then Chuck Hull, he really kicked things off in 1984, invented stereolithography, SLA, and that pretty quickly led to the first commercial 3D printer, the SLA-1, around 1988. Okay, then moving into the 90s, that's when it started gaining real traction in industry, right? Technologies like fused deposition modeling, FDM, and selective laser sintering, SLS, they became the go-to methods, especially for prototyping, cars, planes, that kind of thing.
Right, for industry. But the real shift, the moment that changed everything for everyone else, that was the 2000s because those initial patents started to expire. And that just opened the floodgates. You saw these amazing open source projects pop up like RePrep around 2005. And that paved the way for affordable desktop printers. Companies like MakerBot, Prusa. Suddenly you had this explosion of the maker movement. It put the tech right into people's hands, millions of people. And that momentum just kept building into the 2010s. That decade brought this huge wave of material innovation. Seriously, we're talking breakthroughs in printing metal. The whole field of bioprinting started emerging, printing with multiple materials at once. And suddenly, 3D printing wasn't just for prototypes anymore. It was being adopted widely. Medical, dental, fashion, even construction started taking notice.
Okay, so let's get down to basics. Building layer by layer. What's the core idea here? How does it actually work, regardless of, whether it's plastic or metal or concrete? It all boils down to a digital design file, right? Like a CAD file, blueprint on a computer. And then the printer just meticulously builds the object up from that file, one super thin slice at a time. And the materials, you mentioned metal, but the range today is just, well, it's kind of mind-boggling. It's way beyond just those common plastics like PLA and ABS that maybe people know from hobby printers. Now you're seeing advanced metals, titanium, stainless steel, specialized concrete mixes for houses, different kinds of resins, and even, like you said, cutting-edge biomaterials, hydrogels, living cells, wild stuff.
It really is wild. And what's striking is the sheer versatility, not just the materials, but the techniques themselves. Each method is kind of optimized for different things. Take SLA, stereolithography, that uses UV light to cure liquid resin. It gives you incredibly smooth surfaces, really fine details. You just can't get that with some other methods. So yeah, perfect for things like dental molds or, intricate jewelry. Then you've got FDM, fused deposition modeling. That's probably the one most people picture. Melts plastic, pushes it through a nozzle. Great for quick prototypes, hobbyist stuff. Very common. But for industrial strength, you look at SLS, selective laser sintering. That uses a powerful laser to fuse powdered materials together. Really crucial for strong aerospace parts, automotive components, and for even tougher stuff, industrial metal parts. There's DMLS, direct metal laser sintering. That precisely fuses powdered metals layer by layer. Super precise, super strong. And there's binder jetting. That puts down a liquid binder onto layers of powder, often used for ceramics or complex sand molds for casting. So this huge diversity of methods means you can tailor the solution for almost any industry, any need.
Okay, understanding the how and the what with that sets the stage. But the real aha moments, I think, come when you see what this stuff is actually building. The applications are just incredible, spanning almost every sector you can think of. Let's start with something huge, literally. Construction and housing. You've got companies, Icon in the US, Cobot in Denmark, Apis Core over in Russia. They are literally printing walls, entire homes, in a matter of days, using these special quick-drying concrete or sometimes geopolymer blends. And this isn't just like a novelty. It changes the game for building. Faster, cheaper. It could really democratize housing. Let communities build durable, customized homes incredibly fast. We're talking like potentially 70% less construction time, up to 60% lower labor costs. Think about what that means for disaster relief shelters or military barracks or, crucially, affordable housing.
Absolutely. And it's not just for cities. Think about places where building is normally incredibly hard or expensive. So remote and off-grid locations. This tech is building possibilities there. NASA and the European Space Agency, they're actively looking at 3D printing on the Moon and Mars. The plan is to use local regolith, basically moon dust or Martian soil, as the building material.
Wow, using moon dust.
Yeah. And closer to home, it's already being used. Arctic research bases, remote villages, they can print spare parts, bits of infrastructure right there on site. It completely cuts out the need for these long, expensive, sometimes risky supply chains. Total game changer for remote living.
And the medical sector. That's another area that just seems almost like science fiction sometimes. We're seeing custom prosthetics made perfectly for an individual. Complex implants. You mentioned bioprinting organs are actually under trial right now. It's early days, but still. Plus, things like printed surgical tools tailored for a specific operation. Bone scaffolds to help healing. And mass customization becomes easy for things like dental aligners or hearing aids. Perfect fit every time. Then you have automotive and aerospace. Huge industries. Companies like Boeing, Airbus, SpaceX, they're all using additive manufacturing. Why? To make lighter, stronger components. Lighter means less fuel used, which is massive for cars and especially planes. And for space missions. Imagine being able to print a replacement part during the mission. That's revolutionary for reliability for long trips to Mars or beyond.
Right. But then there are the sectors you might not immediately think of. And this is where it gets really fun, I think. Fashion, food, art. Seriously, you have designers like Iris Van Herpen making these incredibly intricate 3D printed dresses, Adidas printing custom midsoles for shoes. In food, people are printing chocolates, complex pasta shapes, even some experiments with plant-based meat substitutes.
Boosting pasta? Okay.
Yeah, and artists are creating sculptures with geometries that were impossible before. It's not just novelty value. It allows for hyper-personalization. And in fashion, it points towards like zero-waste production. Making only what's needed perfectly fitted challenges the whole mass production model.
So looking ahead then, what does tomorrow look like if today is already this wild? The future seems to be about scaling up, right? You mentioned houses, but bigger structures, multi-story buildings, maybe even high-rise frames. Is that really feasible? It seems like the printer gantries would need to get enormous and mobile.
Exactly. Scale is a big part of it. And yes, multi-story is happening. High-rise frames are definitely on the roadmap. The printer tech, the gantries, they're getting bigger, smarter, more mobile. It's changing urban construction. And alongside scale, you've got relentless material innovation. That's key. Things like graphene, carbon fiber composites, super strong, super light. Using recycled plastic is becoming huge. And developing things like eco-cement. These materials will dominate sustainable additive manufacturing, pushing boundaries, both structurally and environmentally.
And the convergence you hear about. AI and 3D printing. That sounds powerful. What does that actually mean? A printer that thinks, like it learns as it builds, optimizes itself using machine learning, maybe predicts if a print is going to fail before it happens. That would save a lot of time and material.
That's precisely it. Smart printers. Imagine a system that adjusts speed, temperature, material flow on the fly based on sensor feedback, using machine learning to constantly improve strength or surface finish. And yes, predictive failure detection. Analyzing the print layer by layer, spotting microflaws, adjusting course, or stopping before a catastrophic failure. It's a huge leap in reliability and efficiency. And this connects powerfully to the idea of a circular economy. Think about waste to print, taking plastic waste from the ocean or rubble from demolished buildings and converting that directly into printable material. It's already starting to happen. You could have cities with local print farms using local waste streams, maybe automated with robotics, producing goods right where they're needed, cuts transport, uses waste, incredibly efficient resource use.
Okay, and the really, really far out stuff. Space colonization, printing habitats on Mars we talked about, but tools too. Even biological tissue in space. That sounds absolutely essential if we're serious about long-term missions, right? Not launching everything from Earth.
Essential is the right word. You simply can't launch everything you might possibly need for years on Mars. So printing habitats from local materials, yes. Printing tools as needed, absolutely. Printing spare parts for life support or rovers, critical. And yes, the research into printing biological tissue, maybe even food eventually in microgravity, is deep in R&D. It's fundamental for making long-duration space travel and settlement actually viable. It redefines off-world construction.
So this massive transformation, it naturally brings up big questions about jobs, about industry structure. Is it just about jobs disappearing, or is it more complex? It feels like It's not elimination, maybe, but job transformation,
Mhm.
like maybe fewer traditional bricklayers or assembly line workers, but more need for people who can operate these complex machines, material scientists, CAD designers. So upskilling becomes really, really critical. Design thinking, automation skills, robotics.
Transformed is exactly the right way to think about it. Roles evolve. You need people to design the digital models, to prepare the files, to select and manage the materials. You need technicians to operate and maintain the printers, people to do the post-processing, quality control. And yes, material science becomes hugely important, developing and validating new printable materials. So the skills shift, definitely. Upskilling and reskilling are absolutely vital for the workforce. And another really important aspect, often overlooked, is the potential for safer work conditions. Think about construction or mining or working in disaster zones. These can be high-risk jobs. 3D printing, especially when paired with robotics, can automate many of the most dangerous tasks, reduces the need for humans in hazardous environments. And even in factories, less repetitive manual labor means fewer repetitive stress injuries, less exposure to potentially harmful materials or fumes. It makes manufacturing inherently safer.
I also really like the idea of empowerment for small businesses. That seems like a big potential upside. You know, a local entrepreneur, maybe in a remote area or an underserved community, they could potentially get a desktop printer, maybe a slightly more advanced one, and start producing custom parts for local needs, or tools,
Mhm.
or unique home decor, even things like orthopedic supports. Is that really happening? Is it creating the sort of micro manufacturing revolution?
It absolutely is happening. We're seeing it globally. It lowers the barrier to entry for manufacturing dramatically. You don't need a massive factory setup.
Yeah.
So you have small businesses, individual makers, they can design and produce highly customized goods locally. It fosters innovation at a grassroots level. And it's particularly powerful in regions that lack traditional industrial infrastructure. And that decentralization, that local production, it has huge implications for supply chain resilience or disruption, depending on your perspective. Producing things on demand, close to where they're needed, that massively cuts down lead times, reduces inventory costs, and having localized factories, even small ones, makes regions less dependent on those long, complex, sometimes fragile global freight networks.
Yeah, we've seen how fragile those can be
Yeah.
recently.
So local on-demand production makes the whole system much more robust, especially during crises, trade disputes, pandemics, whatever.
Okay, so we've seen the impact sector by sector. Pretty amazing. But let's pull back a bit. You combine 3D printing with these other big trends, robotics, AI. Can this combination truly spark a new manufacturing boom? A renaissance, maybe? It feels like it could. The advantages seem pretty clear, right? First, there's the speed and flexibility. You mentioned no retooling. That means you can iterate designs super fast, print a mold or a jig in hours, not weeks. That's huge. Then, this idea of localized microfactories, small units, close to customers, cuts transport costs, carbon footprint, reduces reliance on far-flung suppliers. It also seems perfect for low-volume, high-mix manufacturing. You know, things where you need lots of different customized items, but not millions of each. Medical devices, aerospace parts, maybe spares for old machines. And finally, sustainable production. You only use the material you need, unlike carving something out of a block. Plus, the potential to use recycled materials we talked about. That's a big environmental win.
You've nailed the key advantages. And yes, when you combine these, especially with robotics and AI, that is the backbone of what people are calling Industry 4.0, the next industrial revolution. It's not just one technology, it's the synergy between them. Think about autonomous production loops, robotic arms loading printers, unloading parts, doing finishing touches, while AI systems monitor everything, detect errors in real time, maybe even optimize the printing parameters on the fly. And intelligent design and optimization, this is fascinating. AI can actually generate designs. You give it the constraints needs to hold this much weight, fit in this space, use this material. And the AI explores thousands, millions of design possibilities, many completely not intuitive to a human.
Like those weird organic-looking structures you sometimes see?
Exactly. That's often generative design. They look strange, but they're incredibly efficient. Often lighter, stronger, using less material, cheaper to produce. And all this automation makes lights-out manufacturing truly possible. Factories that can run 24/7 with almost no people on site. It's already happening in places like Japan, Germany, the US, and certain sectors. The full vision, the end-to-end dream. It's like this. A customer orders a custom product online. An AI optimizes the design instantly. It gets printed, maybe using multiple materials. Robotic arms assemble it or finish it. Then a drone or an autonomous vehicle delivers it, all potentially within hours. Minimal human intervention on the floor.
Wow, incredibly efficient. But okay, the big geopolitical question then. Does this kind of radical shift allow, say, Western nations or others to really compete again with manufacturing giants like China? Can it level the playing field somehow?
Yeah, that's a core part of the discussion. And the argument is yes, absolutely. For countries with higher labor costs, automation effectively neutralizes that traditional low-cost labor advantage. This makes reshoring, bringing manufacturing back home, or nearshoring, bringing it to nearby countries, much more economically viable. It reduces dependence on potentially unstable or distant supply chains, which is a big geopolitical plus. Also, the focus shifts. Instead of competing purely on mass production volume, countries can compete on customization, agility, and innovation. High-value, tailored products. If you have strong R&D, you can build innovation ecosystems around these technologies, create valuable intellectual property. And finally, think about resilience. In times of trade wars, pandemics, blockages, having self-sufficient digital manufacturing capability becomes a huge national strategic advantage. You can circumvent bottlenecks. So what you're seeing here, it's not just a simple tech upgrade. It really is a potential geostrategic shift. Some analysts are even calling it a new Cold War of manufacturing, where nations compete not just on cost, but on technological leadership, supply chain security, and manufacturing independence. It's reshaping the global economic map.
Okay, but like any really powerful technology, it's not all smooth sailing. There must be challenges, ethical issues. What are some of the hurdles or downsides we need to think about? I guess intellectual property is a big one. If designs are digital, they can be copied easily.
That's a major concern. Protecting designs when the blueprint itself is just a digital file that can be shared instantly. It's tough. How do you enforce patents globally when someone can download a file and print an identical copy in their garage? It requires new ways of thinking about IP protection.
And regulation must be lagging behind, especially for things like printed buildings. Are there global safety standards, building codes?
It's catching up, but yes, regulation is a challenge. Developing consistent, internationally recognized standards and building codes for printed structures takes time. That lack of clear regulation can sometimes hinder wider adoption, especially for critical applications where safety is paramount, like housing or medical implants. There are liability questions, too.
And the darker side, weaponization. People talk about 3D printed guns. Is that a realistic concern? Drone parts?
It is a realistic concern, unfortunately. The technology can be misused. While printing a fully functional, reliable firearm is still complex and requires specific materials and printers, the potential is there, and it presents a challenge for law enforcement and security agencies globally. The same applies to parts for drones or other potentially harmful devices. And on a more practical level, there's material safety, day-to-day stuff. Some of the filaments used in common FDM printers, when melted, can release volatile organic compounds, ultrafine particles. So proper ventilation and safety protocols are really important, especially in schools or enclosed office environments, not just industrial settings. We need to be mindful of the potential health impacts. So yeah, putting it all together, 3D printing really does stand at this fascinating crossroads. It's driving a genuine manufacturing revolution. And the applications seem almost boundless, from rapidly building homes in disaster zones or war-torn areas, all the way to potentially enabling sustainable human settlements on Mars. It really forces us to rethink what's possible.
Absolutely. And while, yeah, it's definitely going to reshape jobs, transform industries, it also presents these incredible opportunities for more inclusive innovation, for building more resilient infrastructure, for creating vibrant, hyper-local economies. It feels like a technology that can genuinely empower people and communities. It almost sounds like sci-fi, doesn't it? Thinking that the same basic idea that makes a little plastic trinket could also build our future homes, maybe even on another planet. It just totally redefines what building even means. So maybe the final thought for you listening, the next frontier isn't just printing tools or parts or even houses, it's about printing futures. How do you see 3D printing impacting your world or maybe your industry in the next 10 years? And what role could you play in shaping that future? Something to mull over.